Hey, what's up, guys? This is Mr. Myers. This is the second example for optimization for calculus AB. AB calculus, this is number 2. So let's take a look at it and see what we can do. So I want to remind you of the steps in the procedure for these. The bell's going to ring here soon. One, we're going to choose our variables and draw or label a figure if we can. We're going to write our primary equation and isolate what we need to be maximized and minimized. And we're going to rewrite only in one variable. Okay, so unlike in related rates, sometimes we have two variables. This, we only want one variable. And we want this to be explicit, so we're not doing implicit, only on one side, right? There may be a secondary equation that we might need to use to get one variable, but we're going to want to make sure we only have one variable. We're going to find the domain if the domain is a problem for us, and then we're going to take the derivative, find the critical numbers, and then do our whole number line thing. Okay, so let's take a look at this. The product of two positive numbers. So I'm going to make one positive number x and one positive number y, and I know the product is 28, so I know that the product x times y is going to be 288. Did I say 28? I meant 288. Find the two numbers so that the sum of twice the first, so the sum, we'll just make this S, the sum of twice the first, so twice the first, plus, oh look, there's the bell, plus the second is as small as possible. So I know this is what I'm trying to minimize. I'm trying to minimize this sucker right here. So remember, we don't want it in two variables, right? Even though we have our maximization or minimization, in this case minimization because it's small, our equation here that we want to minimize, we only want it in one variable, so that's why we have our secondary formula here. So let's solve this for x. So x is going to be 288y, and then I'm going to make a substitution in right there. Substitution. That word's fun to say. Substitution. So 2x plus 288 over y. Oh, what am I talking about, Willis? This was supposed to go right here. 288 over y plus y. Okay. Now you could do it the other way too and solve for x. Either way is going to work out fine. So 2 times 288 is 5. I can't even math right now. 576. 576. The y stays in the denominator, so I'm going to bring it up as to the -1 plus y. All right, so now I have my optimization, guys. So I'm going to go ahead and take the derivative. So I'm going to get negative 576 x to the -2. I'm sorry, y to the -2 plus 1. I'm going to go ahead and write this over y squared. Plus 1, derivative of y is 1. And I'm going to set this equal to 0. So first of all, do I have any domain restrictions here? I do have a domain. I have y has to not be equal to 0, right? And if the same thing works over here, if I solve for x, I would have x cannot be equal to 0. So I have to make sure I know that these are true. And in fact, I'm talking positive numbers. So let's just make this greater than 0 right away. Each of these guys is greater than 0. So I'll have to know that once I finish my problem out here. All right, so I'm going to multiply everything by y squared equals 0. Y squared equals 576. Y is going to be plus or minus the square root of 576. But since we don't need a negative, it's going to say the square root of 576, which is 24. All right, so now that is our critical value. So we're going to go ahead and make our little number line here, S prime, 24. And I want to know what's going on both sides of this 24. So I'm going to pick, let's pick, I don't know, 6. Let's pick 6, okay? So if I put 6 in here, 6 squared is going to give me it's going to give me a negative, clearly, right? Something bigger than 24 is going to give me a positive. So it's going to decrease, then increase. That looks to be my minimum right there. All right, so my y value is going to be 24 at my minimum, and my x value is going to be 288 over 24, which is 12. So these are my values such that the product is going to be, or that this thing is going to be as small as possible. All right, so there you go, guys. There's the second example in optimization for essential calculus. See you soon. Bye.